Yeah, some more quantum mechanics and the animal farm. I just came up with a comparison between it's just starting to get old McDonald's had a farm. Quantum mechanic and old McDonald's farm. Yeah, I'm comparing the whole quantum mechanical thing as the macroscopic object can be regarded as a bear, you know, bear, and the particle can be regarded as a lice. And I mean, the bear is not a bold bear; it's a hairy bear. And the lice is interacting, it's a hairy lice, by the way, very hairy lice. It's interacting with the hairs of the bear before it gets to the bear itself. And that's the same as with a wave function, an unbound wave function, a UWF. It's interacting with the non-local wave stuff of the bound wave functions in the screen. You cannot regard the macroscopic world without keeping in mind the quantum mechanical properties of the particle that it consists of. I mean, atoms have quantum mechanical properties, but they are bound. So, but apparently, what quantum mechanics shows us is that it's bound, but that doesn't mean it's entirely confined. The tunneling effect shows us that a macroscopic object, this is just a plant tray, a little plant tray, it has some extension. It has hairs, quantum mechanical hairs, so to say. I don't know how far it extends. And I can imagine that you have to be careful with imaginations. But I can imagine that the extension is very far. I mean, how far does a wave is connected with the rest of the universe? I don't know. But like I said, a hairy lice is interacting with the hairs of a bear before it gets to the bear, and it can suck blood from the bear, and so interacting. We cannot deny the hairiness of objects. I mean, this knife. We have to take in account the hairiness, the non-local. The non-locality of objects via quantum tunneling, of course. And otherwise, an observer can never influence a particle that is in the two slits experiment. If this is the two slits and you put here an observer watching the particles, logically it should not be able to influence the particle's behavior, but it does. That can only be if there is a non-locality aspect of the particle, and so the particles must be hairy, so to say, to interact. They must have some extension into space, including a macroscopic object. Otherwise, it cannot interact. And also including the screen. A macroscopic object like this has some hairiness, so to say. It is like a bear, and it's not a bald bear. It's not a shaven bear. It would be cold, I guess. But also the lice must have some hairiness, some waviness around itself to interact with itself, but also to interact with its surroundings. And the hairy bear theory, I'd like to present to you. Old McDonald's had a farm, and on that farm there was a hairy bear and a hairy lice. Well, I had to come up with some picture, you know. So, but I hope you understand what I mean. Wave particles have some extension including in macroscopic objects. That cannot be, we have to take that in account. Its waviness may be slight. I mean, the majority of the wave is, of course, confined and bound inside the macroscopic object in an energy box. But a light particle is a free outside of an energy box, or at least a larger energy box, in this case a laboratory room or whatever kind of room, but it's confined nonetheless. It's only confined in a bigger space. But once it gets into an object, it becomes part of an object, and it becomes confined in a smaller box. And I think we have to take into account the macroscopic aspects of in quantum mechanics with respect to the microscopic or submicroscopic aspect of matter. Okay, this is what I want to share. Okay, hasta la vista. See you next time. Thanks for watching.